Okay, for your group, because yesterday I haven't teach your one method, which is so-called synthetic division. Okay, so for your group, I'm going to teach that method, that division method by today. Okay, so who is asking the question number 7 just now? What is your name? You are?
Ferdi.
You are?
Ferdi. Lim.
Sorry? Ferdi, okay, Ferdi, yeah, Ferdi.
Yeah.
So let us discuss this question.
Okay.
Okay, can all of you see my screen?
Yes.
Can you all see my screen yet?
Yes.
Yes.
Yes, okay. Basically, about this question number 7. Yes, about this factor theorem or not? Factor theorem. Have you learned before what is factor theorem?
Yeah.
Okay, or else can I ask, have you learned the long division, isn't it? You learned this before?
Yeah.
Yes, okay, I'm going to teach this again for your understanding, okay? Okay, wait for a while. Can we start now? How many of you now? Yes, I think I will start now. Okay, let us start now, yeah? Okay. Why cannot record? Yeah, can record now. Okay, how? So, for this, if say we know that when you try to substitute 3 into this denominator, when we sub x equals to 3 into it, you get it is 0, isn't it? Okay, and therefore we cannot doing substitution. We need to do factorization. Okay, since it can I mean when this okay, I will say that fx will be this polynomial 2x cubed minus 13x squared plus 17x plus 12. If say we have f3 by substitution into this, we get it 0, isn't it? Zero, and therefore we can say that actually x minus 3 is the factor of fx. Have you guys learned that before?
No.
Yes.
No. Okay, never mind.
Yes.
Can I write this before? Okay, can I write this for understanding? If fx can be divisible by x minus 3, that means it will multiply a quotient and add up with a remainder, isn't it? And now the remainder, if it is a factor, if that is a factor, means that the remainder equals to what? Remainder equals to 0, isn't it? Yes or no? Yes or no?
Yes.
Who say no just now? Can you
Yes.
answer now?
Yes, sir.
F3 minus 3
Yes.
will become 0, isn't it? Yes, and therefore x minus 3 will be the factor of fx. Okay, when you know it can be factored by, I mean, it's a factor of this. Okay, that means when we do the long division, we should not have any remainder, isn't it? Okay, so this one I'm going to start again. I'm going to start from this part again. Okay, I'm going to start doing the division again. Okay, when you do long division, 2x cubed minus 13x squared plus 17x plus 12, when divided by x minus 3, okay, then we put 2x squared, isn't it? Okay, then we multiply 2x squared, we get what? 2x cubed, isn't it? Anyone follow? Ferdi, do you follow?
Yes.
Yes, negative 2 times 2x squared will be negative 6x squared. Understand? Yes, Yes, okay. So next, then we have a negative 13x squared minus we will get what? Means that the negative 13x squared minus negative 6x squared, we have last, isn't it? Agree or not? Yes or no?
Yes.
Everyone follow? Okay, we have negative 7x squared plus 17x, and then we're going to continue, isn't it? Okay, and the next one, the next quotient term that we are going to multiply will be, depending on, we want to get negative 7x squared, therefore we need to multiply negative 7x. Everyone understand?
Yes.
Yes, and also we have to use negative 3 to multiply this as well, isn't it? And therefore we get positive 21x. Yes or no? Yes,
Yes.
okay, and by continuing, we have this to become negative 4x plus 12, and lastly we multiply negative 4. Okay, we get negative 4x, then plus 12, and therefore we end up without any remainder. Okay, all right. So at this point, we can say that the denominator can be divided by this x minus 3 with a quotient, and the quotient is this term, which is 2x squared minus 7x minus 4. Everyone got it?
Yes.
Yes, okay, that method, this method, I will, okay, this is so-called the long division. This one is method 1, which I think you have learned it before. All right. So now I'm going to teach you another kind of division, and that division is having a name of so-called syntactic division. Okay. I mean, every one of you, please follow my step. This one is quite important. I mean, very useful for you to use instead of doing this long division. The long division, you have write so many things in it. Okay, but however, for syntactic division, method 2, you can see, for method 2, will be easier by just copy down the dividends. Okay, the dividends which is we copy down the coefficient starting from the x cube coefficient is 2. We copy down 2 minus 13, 17, and 12. Okay, we copy down the coefficient of each of these terms. We copy down x cube coefficient 2, and then we have also negative 13. Yes, everyone is following. Please follow my step to do this. Step. Okay, we have this, and lastly also we have the negative 12 as well. I mean positive 12 as well. Everyone follow? Have you copied down this yet? Yes or no? Yes. Okay. Now draw a straight line down, and here I make this horizontal line as well. Okay. And next, if say I would like to divide by x minus 3. If I would like to divide this term by x minus 3, all right, x minus 3, and therefore the factor itself, this factor itself, and x minus 3 equals to 0. We let that equal 0. Therefore, x must be equals to 3, isn't it? And therefore, I put 3 on this left side. Okay, I'm going to put 3 on this left side because now my divisor is x minus 3. Okay, and therefore, when divisor equals to 0, and that makes the x equal to 3, isn't it? And therefore, I put a 3 on the left side here. Everyone follow? Yes, Yes or no? Can I continue? Yes, okay. The first step will be I'm pulling down the first coefficient. I'm pulling down the first coefficient of 2, and 2 will be here. All right. Okay. Next, I'm going to use this left side 3 to multiply 2, and then we get 6, isn't it? 6, I'm going to write it down here. Just right bottom of -13. Okay. And followed by, I add this 2 value up. -13 plus 6, I get what? -7, isn't it? Everyone follow? Can everyone follow?
Yeah.
Or you want
Yeah.
me to repeat again? No need, Continue,
Yeah.
Okay. Then now the latest one is -7, isn't it? I'm going to use a 3 multiply -7. I get -21, isn't it? Yes, with this -21, I again add up this 17 and -21 to become -4. All right? Yes or no?
Yes.
Yes,
Yes.
And lastly, again, do the same step again. Multiply 3 to -4, and we get what? -12, isn't it? Yes, and therefore we have this. We add this up, become what? 0. The last term will be our remainder, and the first 3 terms will form the quotient. Okay, and that will actually known as the synthetic division. You see my method? I'm now teaching you another kind of synthetic division, which you're using. Instead of using the method 1, you can use that. But now I'm actually teaching you a new method, which is so-called synthetic division. Synthetic division. Okay, this is so-called synthetic division, okay, which we only use the coefficient to work out the quotient and the remainder. And therefore, I can say that these are 2x cubed minus 13x squared plus 17x plus 12 can be factorized as x minus 3 multiplying what? Okay, the last term will be -4x power 0. The second last term will be -7x. Okay, when it is x power 0, actually no need to write, it's a constant. And the first term will be what? 2x squared.
Sir, can you repeat that? My Wi-Fi suddenly stopped. Repeat from the x minus 3.
From the x minus 3.
Yeah.
You mean okay.
From here, okay.
This one will multiply with the quotient plus the remainder. Okay, and the quotient will be what? The quotient that I have obtained from this synthetic division will be these 3 terms. And the first term represent, okay, the last term representing the last -4. All right, and the second term will be the last second term, -7x, and followed by the last one will be 2x squared. Understand? Okay, and because of you have the remainder as 0, isn't it? So remainder no need to write. Okay, that is how we factor it into this part. Understand? Yes or no?
Yes.
So from the right, it always start from x squared 0 lah.
Yeah, not always x squared. I think I start from the last term.
Yeah, from the
last
term. Last
The
term.
last term will be x power of 0, x power 0, x power 1, and x power 2. Yeah. Yes,
Okay.
you may say start from the last term.
Yeah.
Okay, so we can do the same from the numerator. Okay, once we have the denominator to be arranged in this way, that means we can still doing the same for this numerator side. Okay, just now Ferdy asked about this -24, maybe something wrong here. Okay, now I'll try to work out. And show you all. Okay, We have 1, -1, -14, -24, isn't it? Everyone understand? Yes or no? I'm actually extracting the coefficient of each term. Can you see or not? I'm actually
Yes.
extracting the coefficient of each term to be right, okay, in this descending order. Agree or not? Yes, okay, and then followed by, okay, as I mentioned previously, before I start to do this question, if I know that the limit is axis, okay, I should have x minus 3 to be a common factor for both numerator and also the denominator, isn't it? Okay, and therefore I know that this x minus 3 should have can divide this numerator, and therefore I will just use x minus 3 to divide this as well. Okay, to do this again, we let this x minus 3 equals to 0, and therefore I'm going to substitute x to 3 to here. Yes,
So I think 3 is not 0.
Yes.
I think numerator is not 0 when sub in 3.
Oh, is it? I try now. Can I try now?
Yeah.
1, then 3, 2, 6. What do we get? -8, isn't it? Yes, correct. Oh, I think this one should have to be positive. If I change to positive, can
Yeah. Can.
positive. Okay, sorry. I think I made a mistake here. All right. Okay. So that is good whereby we can discuss here. Then we can solve that accordingly. And yes, I think this one I will announce in the Google Classroom. Thanks for pointing out. Okay. So once I have done that one, once I have done this, so I can just write the result based on the quotient here will be what? Since it's only consists of the 3 terms, it should be x squared will be the highest degree of x squared plus 2x minus 8. Yes or no? Everyone follow?
Yes.
Okay, and just now what will be the denominator for the factor for the quotient? What will be this one? Can someone tell the fact? This quotient for this?
2x squared
2x squared
minus 7
minus 7.
minus 7x minus 4.
Okay, thank you so much. Yes, okay. Actually, we do not need to fully factorize it. We do not need that. As long as you have cancel out those factors that will make the denominator 0, I simplify it up to this point, and from this point onwards, you may just do the substitution. You got what I mean? Yes or no? Yes, you may just do the substitution at this point. Okay, and you use calculator to calculate. Okay, and then we have 2 times 9 minus 21 minus 4. It'll be -1, isn't it? Yeah, and then I have the answer, it will be -1 for my final answer. Okay.
I sub everything into 3, right? I still get -1.
You sub everything
The
together
3,
with all.
3, and I put everything into. I change the x equals 3, everything, and then I still get -1.
I don't understand. You change what?
The x cubed minus x squared. The x I change it to everything sub into 3. And I
When you
just
sub this, you can get -1. I mean, how about this one?
huh?
How about this one?
But then the 24 I need to change it to positive 24 lah. If not, I get 0.
Huh?
24. Okay. Now I change my question to be positive 24.
Then
mean?
I sub 3 everything. I sub the x into 3. I change the x into 3, sorry.
You change the x into 3. Okay.
Yeah.
What do you mean by you substitute? Are you using a calculator to do that?
Yep.
Are you telling me you are using a calculator to check the answer, isn't it?
Yep.
Yes or no?
Yep.
Okay. So when you key the calculator, if you key, do you put a bracket for that?
Yes.
Minus alpha x square minus 14x, isn't it?
Yeah.
Yes or no? Then plus 24. Yes or no?
Yep.
Then divide by 2 alpha x cube. Is that a meaning? Are you doing this way?
Yep.
Alpha x square plus 17 alpha x plus 12. Is it? Yes, Then you calculate, you substitute 3.
Yes.
Same arrow.
No.
Calculate. If I press calculate, is it 8, 17 x
17.
plus 12, okay? Then calculate. Okay. Why cannot? Oh, I know why. Because I in statistic format. Okay, I just want to okay, because your friend saying that even he haven't do the factorization, isn't it? You want to mention? You want to deliver saying that even you haven't factorized, you key in calculator into this, you're still getting the answer. Is that a meaning? I'm sorry.
Yeah.
You key in the whole term. But the main point is the denominator is actually 0, isn't it? What do you substitute? You substitute positive 3 or negative 3.
I think I make a big mistake already.
Huh?
Yeah.
If you calculate 3, you do not have a you see or not? You should have a math arrow. You get what I mean? Because when I substitute 3 into that, calculate 3, you shouldn't get any value. Because when you substitute 3 into that, when your denominator is equal to 0, the y is undefined. You get what I mean?
Mm.
Yes or no?
Yeah.
Then how about the rest? How about the rest? Do you follow or not?
Yeah.
I copied down everything already.
Yes, I mean, you have to use this method instead. Okay, when you have x cube, instead of using sometime we can use calculator equation. You press equation and then select degree number 3, and then you can put 1, -1, -14. I want to show you. Okay, and then D is what? 24. Right now. Okay, you have a factor. You have a roots of 3. That roots of 3, that means x equal to 3 will be one answer, and equals again x2 is what? -4. Okay, and then we have x3 to be 2. That means I can factorize it into x minus 3 times x plus 4, and another one, the last one will be x minus 2. You get what I mean? But we do not need to factorize these two. I mean, we do not need to do that. Okay, as long as at some point that we have factorized out x minus 3 to be cancelled out, then from this point onwards, you actually can do the substitution. Okay, everyone clear? I'm sorry about this mistake I've done. I will post that into my my group. Okay, thanks. Thanks for pointing out. Thanks for your group. Okay, so beside of question number 7, okay, how about we can discuss some of these questions starting from question 12 first? Can we do this question first together?
Yes.
Yes, continuous. Okay, this is a continuous question. I think I'm going to go through this one together with all of you. Okay, so for the late, I mean the those previous one, I think as long as you do it together, I mean shouldn't be a problem. But now we can continue to do this question. Question 12. So are you ready? Everyone ready for question 12?
So can you record it?
Yeah, I will start to record. But sometimes I think you can do it together. Okay, this tutorial time we have 1.5 hours, and altogether 14 questions. Better you do it together right now. Okay, so that you won't have this time slot is meant for our really do some exercise. Okay, all right. You need to really explain by your own, not only see and listen without writing anything down. Okay, I'm writing that for many times already. Okay, even prepare for your class also, I write it a few times more. Okay, to make sure that I'm very familiar with that when I'm teaching. Okay, so please, your first time also, you need to really write it down for your own. Okay, can now I'm start to record. Even I will record, but if I record, when you upload to it, you didn't watch it. Also, you will know you will useless. You must do it by your own. Okay, and please do it right now together with me. Okay, can we start now? Can we start? Yes, Yes, I'm going to start now. Okay.
Yes,
right. So for the first question, it asks for question number 12. Does f -1 exist or not? Any volunteer can answer this question?
Yes.
Which function should I substitute when x equals to 1?
-1, not 1.
Okay, x equals -1.
X square minus 1.
Yeah, can you all see this inequality sign? There's an equal sign here, isn't it? Okay, when there's an equal sign here, that means that will be the function that I'm referring to. Okay, and therefore we can say that the f -1, I'm going to substitute into that function, which is -1 square minus 1, which is 1 minus 1, we get 0. Yes? Everyone got this?
Yes.
Yes, okay. B. Then how do we find limit for this question B? Can you see the positive sign there? Yes,
Yeah.
So now everyone can understand what the positive sign means from
The right
side. From the right side means that you are actually looking at the domain x larger than -1, isn't it? Yes or no?
Yes.
Okay, then therefore which we should look at? We are still looking at the same function. Okay, this is -1 less than x. That means x is more than -1. We are still looking at this function. All right. Yeah. And therefore to find this limit also, we actually equals to limit. I'm going to substitute this function as well. -1 plus x square minus 1. Okay. Whereby it is equals to -1 square minus 1, also 0. Understand?
Sir,
Yes.
can we still use the other function since it's larger than -1, right? The other function is also larger than -1.
No, we have to use that particular which is the nearest one. Which is the nearest one? Because if I draw this graph, -1 is here.
Mhm.
Okay, and we have 0. For this domain, for this particular domain, is actually x squared minus 1, isn't it? Okay, if you remember how to draw that one, it's actually it's something like this quadratic. You get what I mean?
Mm.
Yes or no? Okay, so this
Yeah.
is y equals to y1 equals to x squared minus 1. We have to use this particular one because when we say we are actually approaching -1 from the right,
Okay.
isn't it?
Yeah.
We have to referring to this particular. When I say very close to it, when we say
Yeah, yeah.
approaches, when we say approach -1, then we should go back to this particular function, which is x squared minus 1. We
Right.
cannot use others. We cannot use others.
Okay.
Okay, others will be different things. Okay, can so
Okay.
I'm clear on the question A and B for this moment. Yeah, everyone. Any
Yeah.
question on A and B? No, I think I have to print it. I mean, I have to place it at another page. If not, there'll be too much. Okay, for question C and D. Okay, now the question asks. Okay, C. Is f continuous at x equals to -1? Plus, how do we answer this question? If you want to see whether it's continuous, I will always start from to look at whether is there a limit limit at that point or not. Okay, when I want to see if whether it's continuous, I will start from whether limit x approaches -1 exists or not. So anyone can answer me? Is this axis or not? Is this axis? Yes? Anyone can answer?
I think yes.
You think yes? Okay. If yes, can you tell what is the negative from the left side limit? Do we have this limit or not?
Oh, no.
No, yes or no? No, isn't it? Because from the left side, we do not have any function. Y is undefined from the left side. And therefore, the limit x approaches -1 fx is considered as does not exist. All right, when you do not have the limit axis, all right, then you just have to conclude that f is not continuous.
So how do we know on the left is the negative side? It does not exist.
Based on the domain that he has given.
Oh, okay.
Because the graph that just now I mentioned, this one is actually drawn up to a -1 point. Correct or not? You only have the graph up to this point.
Yeah, okay.
And from the left side, we do not have anything.
Okay.
It's blank. Yes, okay, thanks for asking. Again, because here from the left side, the fx limit does not exist. And therefore, we can conclude that the limit for that particular point do not exist as well. Okay, when the limit does not exist, and lastly, the conclusion is what? F is not continuous at x equal 1, -1. All right? Everyone follow?
Yes.
Yeah.
Yes, okay, then how about 1? How about 1? Okay, I think I should have draw the graph. Also, it will be better. If I draw the graph out, it will be better for your understanding. Okay, again, if you're not so familiar, I will I will advise you to draw this graph for your understanding, for you to understand whether, okay, I mean, how do we analyze from the graph the limit is. Okay, so maybe we can start from -1 to 0. Okay, we have this graph. Okay, so starting from -1 and 0, we have this. Correct. Okay, that will be y1 equals to x squared minus 1. Okay, when it is 0, okay, here you may say that, okay, because here we do not include 0, isn't it? And therefore, this I will put a hole. That's what I'm saying, because it's not included. Okay, when come to the second function is meant for the domain of 0 to 1, isn't it? Yes or no? Okay, and therefore, because of this equal sign here, when it is 0, okay, it is a solid point there. Okay, up to some point when x equals to 1, you have that become 2, isn't it? Yes or no? But again, here, because it's not included, then I give a hole here as well. Everyone follow?
Yes.
So how do we know the graph is a line or curved?
Why?
Or it doesn't matter.
Which one?
The line, is it curved or straight line?
Oh, that one is a quadratic one. That one is a basic one. I'm not sure about your basic one. Quadratic one. You know what is quadratic?
Okay.
Huh?
Okay, sorry.
No, it's okay. It's okay. Thanks for
I
asking.
just realized.
Okay. All right. Okay. And then the third one is starting from x equals to 1. Okay. You see, the third one is only a single coordinate, isn't it? X equal to 1 and is y equal to 1. That means here I have a special point 1, 1, isn't it? Okay. Then I jump to the fourth. This fourth, okay, the fourth graph will be okay, I will give a table 2x plus 4. Okay, starting from 1, I have 2. If 2, I have it to be 0, isn't it? Yes, okay, that means I have this 2, 0. Okay, that means the fourth graph will be here. Correct now? Yeah. And both points here will actually having a point here. Correct now? Because it does not include that point. Y3 equals to minus 2x plus 4. Okay, and lastly, 2 to 3 will be all 0. Yeah. Everyone follow? Up to 3, up to 3 only. Up to 3 only. Okay, you have the last graph is up to positive 3 only.
So why is there 2 zeros?
Which one?
The first one and the second, and the rest, there's 2 0 in the middle and the bottom.
You mean this? You mean this one? This one?
Yeah, that one.
Okay, that one because when I draw this graph, can you see it's not included 0?
Yes.
When it's not included 0, means that it do not include that particular point. Okay, and therefore we put a break there. Okay, because the 0 will be included in the next function. The 0 will be included in the next function. Will be here. Right now.
Okay. So
Yes,
that means the bottom one is not a 0. It's just that to identify there's something over there.
Yeah, there's a break over there. There's a break over there.
All right.
There's a break over there. Okay, there's a hollow point over there. There's a break over there. Okay, there's a break over there means that means that we have another point. Can you see or not? Another point is here,
Yes.
Okay. Because if I draw this out, it'll be easier for you to understanding. Okay, again, the question Donkey asked about is f continuous at x equals to 1? Can you follow? Can you have some discussion? How do we start? The limit, the limit exists or not?
The limit, it does not exist.
To the one more. Is it? Okay, can you do together? If I want to find the limit from the left, how
Okay.
do I do this from the left side limit?
The limit will be 2.
How do we get that?
It's
On
Which
the break,
function are you following?
from y2,
Y2 is what?
2x.
Yes. Who's the guy asking just now? You
me,
understand?
Chuping.
Chuping, do you understand or not? I'm not
Yes.
doing this 2x and therefore we have 2 multiplied to 1, which is 2, isn't it?
Yes.
Yes, and then how about the right side limit?
Still
Which
2.
function you should substitute?
Which function should I say?
This one, isn't it? Yes or no?
I don't know.
From the right. Can you see this positive sign here?
Yes.
Yes, that means when I have some value point which is from the right, very near to this point, this point lies on which function?
On the 2x. No, it lies on the negative 2x plus 4.
Yes, when you do substitution, what do we get?
Negative 2. Wait. 2.
2. So are they the same?
Same.
Same. So if limit left and right same, does the limit exist?
It does.
Yeah, it exists. Just now you said no exists, isn't it? Now you know the concept or not? The limit still exists even there's a break. There's a break over there, it doesn't mean that the limit does not exist. The limits still are heading to still approaching the same point, isn't it?
Mm-hmm.
Is it not? The limit still exists. Okay?
Right. Okay.
Yes, the limit still exists. The limit x approaches 1, fx,
Okay.
still exist as equals to what? 2. Alright? Understand?
Right. Understood.
But however, when x equals 1, what is the f1 value? What is the f1 value?
f1 value equals to 2.
Yeah, no. Can you see or not?
Which one? Or 1?
Equals to what? 1, isn't it?
Yes.
Are they the same? Are they the same? The
Not
limit
same.
and the not same, isn't it? Because of even you have the limit axis, but it not equals to f1, isn't it? And therefore, f is not continuous at x equals to 1. Understand?
Okay.
You have to watch the video 1.4. I think you haven't watched it, isn't it? Have you?
Haven't.
Haven't, okay, therefore you don't understand this concept. How about others? Have you watched the 1.4 continuous function yet?
Yes.
Yes.
Yes, if you have watched that, you should have this concept, isn't it?
Yeah.
Yes, okay, even you haven't watched, okay, what is the guy again? What is your name again? The guy who asking just now? Chubing, can you ask one more thing? How about limit at x equals approaches 0? How to find that? How to find this one?
Limit x approach to 0.
Yes.
We use 2x as a function.
2x as a function for the positive or negative. There are 2 functions there. Can you see or not?
Yeah.
So from the left side, you cannot only tell one function only. You have to tell me that, okay, you have to inform that, okay, we have from the left side limit, then which function should I substitute?
From the left, from the left, I think x squared minus 1.
Yes, you should referring to from the left side, isn't it? Is it not? Therefore, I'm going to substitute x squared minus 1 for that, which is, you get -1. Agree or not?
Agree.
Yes, and on the other hand, if you find the limit from the right side, I'm going to substitute 2x for that, isn't it?
Yes.
Which you get what?
2x2 0.
0. You know how to look at from the graph or not?
Yeah, I do.
Yes, yes, you can. This one is 0. This one is -1. So very obvious. From the right side limit and the left side limit, they're definitely going to the other value, isn't it? And therefore, the limit at that particular point definitely does not exist. Understand what I'm saying?
Understood.
Yes, okay. That is the very important part, whether the limit exists or not. Because if you do not understand about whether the limit exists, then the continuous part, even you also can't understand.
Okay, thank you, sir.
Thanks, So for the part donkey, if f is continuous, you have to get 3 things. The first one, the left limit 2, the right limit 2. Therefore, then only we can conclude that both side limit are the same. Then only we can say is continuous. I mean, sorry, is limit is exists. But however, when compared with f1, they are not the same. If the limit does not equal to fc, and therefore you can say that f is not continuous at that point because there's a break here. This point do not located at this point. I mean, it doesn't located on this line. If it located on this line, then only we can say is a continuous function. You want to follow? Can you follow?
Yes.
For question 12? Yes, okay. Now we're going to continue on this EFG. Okay, I'm going to copy down this as well. Okay, so again, if for those who not so familiar, how do we look at this piecewise function? I will recommend you, I will advise you to draw the graph out, and then we can check from the graph will be more easier. Okay, right. So I'm going to continue for this one. Okay, E. Okay, again, for question E, if you want to check whether it's continuous, we always will start from, which is, we find the left limit. X approaches 2 minus fx will equals to limit. Okay, from the left side, which is less than 2, isn't it? Less than 2, I will substitute into this guy, which is -2 x plus 4. Okay, and then we have -2 times 2 plus 4, which is 0. Yes, okay, and the right side limit 2 plus fx. So I will see the workings of 2 plus, and this I will substitute 0 as well. I mean 0 for this function because of this domain, isn't it? When x larger than 2, we're going to substitute 0, and therefore we get 0 as well. 0 as well. Okay, but however, okay, even at this point, you can say that you can mention that because of the both side limit are the same, so that the limit x approaches 2 fx axis and equals to 0, isn't it? Okay, but however, the f2, do we have f2 value? Any defined f2 value from here? Yes or no?
No.
Yes or no? No, it's undefined. F2 is undefined because we do not have equal sign here, right? We cannot substitute that because both of that domain do not include, okay, both domain, I mean both domain does not include x equal to 2. Okay, there are no equal sign there, and therefore, which make the F2 is undefined. When F2 is undefined, then we can just write F is not continuous at x equals to 2. Understand? Yes or no?
Yes.
Yes, okay. This part, okay, for this sub question E, I would like to jump into question G to answer G also. So for F to be continuous, okay, for F to be continuous at x equals to 2, my F2 value should have same as the limit value, which is equals to 0. As I'm saying, can you see the question or not? He asks you, what should we assign for F2 so that to make it continuous? So I will answer in such a way that for making F to be continuous at this point, then I will define that to be the same value to our limit value. Everyone follow?
Yes.
Yes, okay, so now the question asks, at what values of x, okay, the F is discontinuous. So can you answer this one? At this point? Just now you have find many points, isn't it? Or we can just look at this point. We can have at what continuous, at what point it's not continuous. We have -1, we have 0, 1, 0, and 3. You get what I mean? Okay, we have all these points. They are not continuous. Okay, so the answer for these are continuous. Okay, at what values of x will be starting from -1, 0, 1, 2, and 3 for this answer. Okay, and again, for answering H, to what value should F1 to be to make F is continuous at x equal to 1? Okay, so for the last question, I will go back to question donkey. You see, because just now the limit will be exist when, okay, when x, the limit is equal to 2, isn't it? To make it continuous, again, for the last question, H, for F continuous at that particular one, x equals to 1, the F1 value must have same as your limit value, which is equals to 2 as well. Okay, 2 instead, and that will be your last question answer. Okay, everyone follow? Yes or no?
Yes.
Okay. Any more question?
Sir, can you repeat why the E is not continuous?
Why the E is not continuous? Which part of the E? Okay, and wait. Why the E is not continuous? Okay, because if I refer back to the, you see this graph or not? I
Yes,
just
I
draw, sketch this graph.
Uh-huh.
You see at 2, at that particular 2, is there a break there?
Yes, I do.
So can you tell what is F2 value? Is there any F2 value?
F2 value. we can take the 2x for the
F2.
limit when the limit
X equal to 2. Do we have this value?
no?
Yes or no?
Mm-hmm.
Do you have this value?
Which value? I
F2,
don't.
F2. When x equal to 2, do we have y, the corresponding y value?
0.
0. Is it 0? Can you see the equality sign here? Is it include 2?
It does not.
Does not. Then how do you define this one? Cannot be 0. Because it doesn't have the include sign here.
Okay.
You get what I mean? Yes or no?
Yes.
Because it do not have this include sign here,
Okay. Okay.
right? And therefore, we cannot say that the f2 equals to 0. You
Oh.
cannot substitute into both functions. Have you listened to this or not? Because both also do not have include sign.
All right.
That means you cannot substitute both. If compared to 1, f1, can we define f1?
Yes.
F1 equals to what?
F1 equals to 1.
Yes, to 1. Then how about f0? F0 equals to what?
F0 equals to 2x.
2x are 2
0.
times 0, isn't it?
Ah.
Because we have seen that there's an include sign for x larger and equals to 0, isn't it? And therefore, we have to substitute 0 to 2x function. Agree or not?
Agree.
Yes, but when we want to find f2, do we have f2 value? No.
We don't.
We cannot define this, and therefore we say f2 is undefined. All right, even I have the limit, but f2 is undefined, and therefore it is not continuous.
Okay, thank you.
Yes, and therefore then only we have another question asked. Then what will be your answer? What is the answer that you should assign to f2 to make it continuous? Right, and then I said it must be 0. Everyone understand?
Mm-hmm.
Yes, right. Okay, I think I stop this video for a while. This one I stop recording. For this question 12, So are you doing your tutorial question now? All of you?
Sure, I have uncertainty on question number 10, E and F.
Sorry?
I want to double check with you with the question 10, E and F.
10 E and F.
Yep.
Okay. This one, does this fx exist at every point from -1 to 1? Or maybe you do not know how to see this one. This one actually is an interval.
Yeah, I don't know how to see.
Okay. Maybe this one I would like to record down the video. Okay, maybe I haven't covered this yet. Yeah. Question 10. Question 10. Okay, class, you see, for question number 10, question number 10, there's a bracket -1 and 1. This is actually, this is actually not a coordinate. It's not a coordinate. It's actually an interval of x, which is the domain of x. Instead, when you have -1 and 1, all right, this is actually representing x. It lies between -1 to 1. Okay, you may always refer back to my 1.4 continuous video. I have talked about that in the video. Okay, which means that is the function whereby when the domain is lies between -1 to 1. Okay, and which we are going to look at this particular Here or not, isn't it? From here to here and also here. Yes or no? We're going to look at this domain. So can you see from the graph, does the limit exist at every point of this? Yes or no? Yes or no?
Yes.
Yes, correct. Then how about from 1 to 3? Does every point of this having is the limit?
My answer is no, but I'm not sure.
Limit exists or not? Why no? Can I ask why you say it's no? Why you say you mention no? Which limit does not exist? As we observe from here.
The positive, the lim xc positive, they only have the left side, don't have the right side. So it count as do not exist. So
Okay,
I say
but can you see the sign here? Is it
yeah.
include 1 and 3?
Nope.
Therefore, for this interval not include 1 and 3, okay, I'm not talking about 1 and 3, but I say for this 1 and 3 in between,
Yeah.
we are still having all to be limit axis. Correct or not? Unless I change my question to be include. Then only I say that at this one, we do not have the limit. You understand what I'm saying? Because now the interval that he would like to ask to look into does not include 1. We do not want to care about 1. We only want to care about the values that lies between 1 and 3, but do not include 1. Okay, and therefore here is yes, actually.
Okay.
Understand?
Yeah. Thank you, Chair.
Unless I change my question to be a C in this 1 to 3. Then also only I say no. Why? Because it do not exist at limit x approaches 1 fx. This one does not exist. Okay, and therefore no. But this case yes. Okay.
Oh, so it is because of the bracket.
Yeah. Because of the bracket. The curved bracket and this square bracket will be different. Curve is actually
even the whole is still included.
the whole one, the limit still there.
So it's still included.
Yeah, still included.
Okay.
The whole limit is actually, the limit approaches 2 is still having the limit. You agree or not? The 2 fx limit are still there, equals to 1. Just that the f2 not equals to 1, but equals to what? 2, isn't it? So I say that the limit x approaches 2 not equals to f2, and therefore f is not continuous at x equals to 2. Understand?
Yeah.
Yes, do you understand about the this
Sure.
or not? Yes.
Then what about the square bracket?
Okay, the square bracket is actually include that value. Okay, maybe I talk somewhere on here. Okay, if I have this means what? The square bracket means you include. If I have this, means what? Okay, now.
Wait,
Do you
sure. So
understand?
one bracket and then one normal bracket.
Yeah.
Is it? Oh, okay.
If square bracket, that means you include. If both are curve bracket means not include. If both are square bracket, means what? Both are included. Understand what I'm saying?
Yep.
Yes, that will be the x interval. X interval. It's not a coordinate, it's an x interval. Okay. All right. So any more question on this 13 questions.
Yes, sir. Number 10, C and D.
Can you answer my question? Number 10, C and D. Yes. Okay. If you want to find
Yes, sir.
one, what's your name?
Garrick, sir.
Okay, Garrett. If I want to find limit x approaches
Yeah.
1, how should I write? How should I do C?
C.
I ask you back.
Just one.
How do I solve this question?
Just a moment, sir. I have to see both side, left and the right.
Okay, so if I put
Is it-
negative sign, that means what?
To the right, to the left.
From left. From left is from
Yeah,
here.
from left.
From Correct or not?
Yes, sir.
Is it not? So can you tell from the graph,
Yes, sir.
if from left, what is the y variable approach value? Y approach which value? You know how
Two.
to see or not? Yes, Correct or not?
Yes, sir.
Yes,
Yeah.
Then how about the right side limit?
Yes, sir. The 1 and the 3, the whole line.
Which is?
Which is 1.
Which is 1. So are they the same? Are
Yeah.
they the same? Yes, or
1.
not? Are they the same or not?
Oh,
Are they same or not?
they are not the same.
They're not the same. They are not
No.
approaching the same value. One is going up to 2,
They're not the
the other
same.
is going to 1. Not the same. If they are not the same, then how? Limit access or not? Is that the limit is access?
No.
No, because they are not the same value. Because the left limit
Same. Okay.
not equals to the right limit. Yes or no? And therefore, the
So as
limit,
long as both
Mm.
does not exist.
yes,
So as long as both side doesn't match up the same number, so they are not existed, right, sir?
yes, correct. Thanks
Okay, thank you, sir.
for keep on remind us. Okay, thanks. Thanks for the clarification. Yes, correct. When your left
Thank you,
limit
sir.
and right limit, they are not meet at the same point, we say that the limit at that point will not exist. Okay or not? What's your name again?
Garrick, sir.
Garrick. Then how about 2?
Yes, sir.
Yes or no? At 2, do they have a limit?
2.
Yes or not? 2 is what?
Yes.
2 is
Yes.
what? Equals to what?
1.
1, no? Then how about 0?
2.
Are they
2 equals to
equal the
1.
same?
Yeah.
0.
0. 0.
From the left, from the right, also.
Yeah, they are the same.
Also, is what?
Equals to 0.
0, isn't it?
0.
Okay.
Oh, okay.
Yes,
Yeah.
Finally,
Yeah, understood, sir.
Okay. Thank you.
Yes. Oh, yeah. Thank you, sir.
Okay. Any more question?
No, yeah, that's about it.
No, sir.
Yes, everyone can do. Yes or no?
Yes.
Okay, I will. Can you show your work now? Everyone doing it, isn't it?
Entering it. They are just holding.
Okay, I give you all up to 250. Then I start to take attendance.
Wait, so after 250, then the attendance is not allowed to take already.
Oh, are you doing now? You're not doing.
So are you Do you mean like submit into the Google Classroom or what?
Google Classroom. Google Classroom. Submit to Google Classroom. Yes, correct. Okay, remember this one I have give you
Okay, sir.
the assignment. Okay, like this guy, Junji. Junji, I'm not sure which group. Okay, he has submitted. Then from this submitted, I will see the workings. Yeah. But minus 24 or he get infinity. Okay, never mind. This one I will discuss with him later on.
Submitted already.
Immediately. Okay. Ong Jalik lah. Okay, Ong Jalik lah. So Ong Jalik, you may leave now if you submitted.
Okay, thank you, Chair.
Okay. Okay, the rest please notify me or you have any question to ask, you may ask now. Okay, I will
Sir.
do such a way, okay? Yes. Please.
For question 14, no need to do it.
Question 14, why no need to do? Find the discontinuous. How do we find the continuous? Discontinuous?
And the root.
Find the root of what? Find the root of?
The denominator.
Yeah, when this equals 0, the
Oh,
fx is
yeah.
undefined. It's
Yeah,
undefined, isn't it?
Mm.
And therefore, the discontinuity will be happen when this equals 0. And again, you may use the method of what you have learned
Synthetic
previously.
division.
1, 5, -4, -40, 24. Okay, you may try to use a 1, 6, 4. Cannot. Try another one.
So this is all trial and error.
It's not to say try and error lah, because you have calculator lah. Yes or no? You have calculator lah. You can press 1,
Okay.
1, and then 5, -2, and then -24. You have 2, 2, 4, isn't it? Okay, then I can start with 2 lah. I can start with 2 first. I can start doing from 2 2, 7, 14, 12, isn't it? Okay,
Oh,
that means you can now do the first one. X minus 2. And this is what? This will be
X
x
squared
squared plus 7x
7x.
plus 12, isn't it?
Oh, yes.
Yeah, okay. For this second degree, I think you should have know how to factorize it, isn't it?
Oh, yeah.
Yes, 2, 4 and 3, 4 and 3. Isn't it? Yes or no? So after you fully factorize it, okay, even this quadratic also you can do one more time. You can do 4 negative, okay, you should put -4,
Oh, yeah,
negative
yeah.
9, and then 1, -4, you get what? 3, isn't it?
3.
Is it or not?
0.
Yeah, and then once you have this 1 plus 3, this is what? X plus 3,
Oh, yeah.
yes or no?
Yeah.
Correct or not? Okay, that is so-called the synthetic. I mean, synthetic division is quite fast, quite useful. Understand?
Yes, I understand.
Yes, okay. Hopefully your group can do it. Okay. Okay, or not?
Yeah, okay.
Yes, today I give you a chance. Means that you have to submit your work at the end of this class. Okay. Starting from next week, I'm going to take attendance. Before you leave the time, I'm going to take attendance to see whether you have submitted your work or not. Okay, so better before you come to tutorial class, spend some time, do half of the question. And when come to the class, you do the rest. You do the rest.
I haven't finished my questions because it's now I erased some of them because all wrong.
Sorry?
I erased a few of my questions. I need to redo it. I don't think I have enough
Need
time.
some correction. We need to do some correction.
I
Okay.
erased everything already.
I mean, next week onwards, you have to submit on time. Okay? Can.
Yeah.
Okay.
Yeah. So now I take attendance for your, I call your name, then you respond to me. Okay, Chai Cho Wei, are you here?
Yes, teacher.
Chong Jin Jian,
Yes, I'm here.
Chong Jian Yen,
Yes.
Chua Ka Sing, not in.
I
Yes. Chua Yi Heng, Chua Yi Heng, are you here?
Yeah.
Sorry, are you here? Yes, sir. Desmond,
Yeah.
Faris, Ferdy,
Yes.
Gary,
Yes.
Kam Yik
I'm here.
Ho,
Yes.
Lee Kuan Ting,
Yes.
Law Siu Lun,
Yes.
Ka Fei, Ka Fei, not in. Sham Zhen Wen,
Yes.
Tan Raymond,
Yes.
Tam Jun Ming, not in. Wong Chiu Ping,
Here.
Wong Li Chen,
Yes.
Wong Shen Wei,
Yes.
Fan Jun Ming, not in. Ka Fei, are you here?
So
Yes,
I'm Jimmy.
you are. Oh, Tam Jun Ming, okay. Ka Fei, Ka Fei not in. Oh, you have trapped me. Do you know who is Ka Fei? Ka Fei is here, but I think he's not here. Ka Fei, I saw his name here. Maybe he log in and then he go to sleep. Huh? Ka Fei? You know anyone know him or not? So who know Ka Fei? Okay, I will upload this for your reference. Okay, I'm upload the tutorial question that I discussed. Okay, the tutorial question I've gone through. Okay, for your reference. Okay, I'm going to upload now. So I think that's it for today. Right.
Sir,
So, yes.
the attendance yesterday, I think you didn't take. Is it for the lecture one?
Oh, okay. I go to take later on. Okay, I go to take later.
Okay. Thank you.
Thanks for the remind. Okay, thank you. Okay, so I think that's it for today. Thank you so much. So
Thank you, sir.
Okay, thank you. I upload this to the Google Classroom.
Thank you, sir.
Thanks.
Thank
Okay.
you.
Thank
Thank
you.
you, sir.